Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we'll study about the definition of the power quality and different terminology associated with the power quality. We start with the definition of the power quality. Power quality is a set of electrical boundaries that allows a piece of equipment to function in its intended manner without significant loss of performance or life expectancy. So here performance and life expectancy is very important. All the equipment should work as it is defined, its performance, and life expectancy should be as it is designed. So we should provide a power in such a way, in such a quality that equipment can function in its intended manner without a loss of performance and life expectancy. Now let us study certain terminology associated with the power quality. Bonding, intentional electrical interconnecting of conductive parts to ensure common electrical potential between the bonded parts. Normally, we do bonding with a very low resistance conducting part of two equipments to ensure both the equipments are at a similar potential. That is why bonding is required. Capacitance, property of a circuit element characterized by an insulating medium contained between two conductive parts. Coupling, process by which energy or electrical noise in one circuit can be transferred to another circuit that may or may not be electrically connected to it. In all the rotating equipment, we know that we have magnetic coupling, and through the air gap or magnetic coupling we call it, we can transfer energy from one circuit to another circuit without electrically connected. Crest factor, ratio between the peak value and the RMS value of a periodic wave, that is known as a crest factor. We take a peak value as a 1 and RMS value, that is a 0.707. In case of pure sinusoidal wave, crest factor, that is 1 divided by 0.707, and then it comes 1.414. Crest factor is normally to identify whether the waveform has a distortion or not. Because in pure sine wave we know that what exactly crest factor is. If there is a deviation, then we can identify that there is a distortion in the waveform. So distortion, qualitative terms indicating the deviation of a periodic wave from its ideal waveform characteristic. So we can see in the diagram waveform with pure sinusoidal waveform and again waveform with distortion. And distortion factor, ratio of the RMS of the harmonic content of a periodic wave to the RMS of the fundamental content of the wave, and that is normally expressed as a percentage. This is also known as total harmonic distortion. Flicker, variation of input voltage sufficient enough in duration to allow visual observation of a change in electrical light source intensity. Form factor, ratio between the RMS value and the average value of a periodic waveform. Frequency, number of complete cycle of a periodic wave in a unit time. Normally we take a 1 second unit time. Ground electrode, conductor or a body of conductors in intimate contact with the earth for the purpose of providing a connection with the ground. Ground grid, system of interconnected bare conductors arranged in a pattern over a specified area and buried below the surface of the earth, and then it is known as a ground grid. Same way we have ground ring, a ring encircling the building or a structure in direct contact with the earth. Grounding, conducting connection by which an electrical circuit can be connected to the earth. We have bonding as well as grounding. We have represented in the diagram bonding as well as grounding. Harmonic, sinusoidal component of a periodic wave having a frequency that is an integral multiple of the fundamental frequency. Suppose if we have a fundamental frequency of 50 Hz, then we have harmonic content might have integral of 50 Hz, that is a 150 or a 300, something like this. Harmonic distortion, quantitative representation of the distortion from a pure sinusoidal waveform. Impulse, traditionally used to indicate a short duration over voltage event with certain rise and fall characteristic. In modern standards, impulse is considered as a transient. Inductance. Inductance is the relationship between the magnetic lines of flux linking a circuit due to the current I producing the flux. We have self-inductance as well as mutual inductance. Inrush, a large current that a load draws when initially turned on. Interruption, complete loss of voltage or current for a time period. Isolation, means by which energized electrical circuits are uncoupled from each other. In case of two-winding transformer, we know that both the windings are isolated from each other. Linear load, electrical load which is in steady state operation presents essentially constant impedance to the power source throughout the cycle of applied voltage. Electrical noise is unwanted electrical signal that produce undesirable effects in the circuits of control system in which they occur. In diagram we can see that our waveform is content with noise. Non-linear load, electrical load that draws current discontinuously or whose impedance varies during each cycle of the input AC voltage waveform. Notch, disturbance of the normal power voltage waveform lasting less than half a cycle. Normally notch is subtractive in characteristic. Periodic, a voltage or current is periodic if the value of the function at time t is equal to the value at time t plus t, capital T. So here we have time period t and t plus t, we have same value. So waveform is known as a periodic. Power disturbance, any deviation from the nominal value of the input AC characteristic, then it is known as a power disturbance. Power factor, we have displacement power factor, ratio between the active power of the fundamental wave to the apparent power of the fundamental wave. In case of pure sinusoidal wave, we have displacement of voltage and current, and cosine of this displacement can be considered as a power factor. Power factor total, ratio of the total active to the total apparent power of the composite wave, including all harmonic frequency components. So displacement increase. So power factor, total power factor because of harmonics reduce. Recovery time, interval required for output voltage or current to return to a value within specification after step load or line changes. Ride through, measure of the ability of control device to sustain operation when subject to partial or total loss of power of a specified duration. Shag, RMS reduction in the SC voltage at power frequency from half of a cycle to a few seconds cycle. Here in the diagram we can see the reduction of the SC voltage for 4 cycles. After 4 cycles it restores its original nominal value. Surge, electrical transient characterized by a sharp increase in voltage or current. Swell, RMS increase in AC voltage at power frequency from half of a cycle to a few seconds cycle. In diagram we can see increase in the nominal AC voltage for 2 cycle of time. Transient, subcycle disturbance in the AC waveform evidenced by a sharp brief discontinuity of the waveform. In diagram we can see the transient. There may be a several reason for the transient. In diagram it is indicated by switching in the induction motor having power factor correcting capacitors. So this is known as transient. Thank you for watching my video. Keep watching. Thank you very much.